In our lesson yesterday, we learned about a new type of function called a piecewise function. And we learned that a piecewise function has different rules for different x values, for different parts of his domain. So piecewise functions are actually broken into pieces. And we evaluated them yesterday. Which means that we had an input value and plugged it in to get an output value. And we choose which rule to use based on where our x value fits into the domain. Now, what we are going to do today is we are going to take those same piecewise functions and we are going to be graphing. So today our focus is going to be on graphing these piecewise functions. Now you will remember from earlier in our work on functions, we graphed by making a function table. A function table where we wrote down the inputs that we were putting into our function and then used the rule to find the outputs, and then that made ordered pairs that we could then plot to make a graph. So the same kind of thing is going to go on today. We're going to be making those function tables again, but we are going to have to make a table for a function table for each piece of that piecewise function. Okay? Now before we get into this, I need to remind you about something. A little bit earlier in the year, we were graphing inequalities on a number line. So we were graphing things like x is less than 7, x is greater than or equal to 5. And what I need to remind you about here is that when we had less than or greater than, and these were not underlined, the equal to sign was not included, that for these problems we used an open circle. And then when we had less than or equal to, greater than or equal to, when we had the equal to bar there, I want you to remember that we used a closed or a filled in circle. And I need to remind you about that because that's going to come into play again today as we graph these piecewise functions. So less than, greater than, open circle, less than or equal to, greater than or equal to, closed circle. And I'll show you where that fits in as we go through this. All right, so here is our first example. We are going to graph f of x equals 2x plus 1 if x is less than or equal to a negative 1, and 3x if x is greater than negative 1. So what we have here is a piecewise function that is going to be broken into two pieces. So your graph is going to be in two pieces. I want you to notice that we're going to use the rule 2 times x plus 1 if our x values are less than or equal to a negative 1. So negative 1 or smaller. And we're going to use the rule 3x if our x values are greater than negative 1, so bigger than negative 1. So here's the domain for this first rule. Here's the domain for this second rule. Now, to graph this, what you're going to have to actually do is make two tables. So we're going to make a function table for the rule 2x plus 1. And then you're going to make a function table for the rule f of x is equal to 3x. Now, in each of these tables, I am going to want 3 inputs, at least 3 inputs in each table. All right, now let's talk about f of x is equal to 2x plus 1. When I go to graph this, the most important thing is that I stick to the domain that I was given. So for 2x plus 1, here's what I know about x values. X values have to be less than or equal to negative 1. Now I want you to notice, negative 1 is a pretty important number here. So negative 1 has to be in your table. That one you don't get a choice on. Negative 1 has to be in your table because it's specifically mentioned in the domain. So that one you have to do. Now, you get to choose two others, but they have to fit what this domain says. The x's you pick have to be less than or equal to a negative 1. So we could do negative 2, and we could do negative 3. Both of those are numbers that are less than a negative 1. So there's going to be what I'm going to do for that first function table. Now, for f of x is equal to 3x, for f of x is equal to 3x, again, to pick my numbers over here, I need to consider what my domain is. And for that piece of the function, my domain says that x has to be greater than negative 1. Now, I know that x can't be equal to negative 1 on this one, but because this domain specifically mentions negative 1, I still want you to put that in the table. I still want you to put it there, and I'm going to explain why when we get this graph done in just a minute. So whatever number is specifically mentioned in these domains, they have to be a part of your table. So notice both of these mention negative 1, so I'm going to have negative 1 in both of my tables. You have to use what the domain specifically mentions, but then you can pick from there. So this says that x has to be greater than negative 1. So 0 fits that description and 1 fits that description. I would recommend, since you're graphing, that you definitely keep the numbers as small as possible because you want your graph to be as simple as it can be. All right, so now let's talk about this for just a minute. I made you put negative 1 in both of your tables because negative 1 was specifically mentioned in both of these domains. So that's why I'm making you put it in there, because it was specifically mentioned in both domains. Now, here is the deal. This top one says that x is less than or equal to a negative 1. Less than or equal to. So it can be equal to. So when you graph this point over here, you're going to use a filled-in circle to graph it. For x greater than negative 1, this doesn't say that x can be equal to a negative 1. What you're going to do over here is when you graph it on this one, you're going to put an open circle. So these numbers that were specifically mentioned in your domains, when you put them on your graph, they are either going to get an open circle or a closed circle. And you're going to determine that by looking for that equal to bar. Negative 1 over here is going to get a filled-in circle because it says x can be equal to negative 1. Negative 1 over here is going to get an open circle because it says x can't be equal to negative 1. He can only be greater. All right, so now let's complete these tables. We know how to do this. We complete these tables by inputting these x's to produce the outputs, which are the y's. So plug negative 1 into this rule. You're going to do 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. All right, now we're going to input negative 2 for this x. So 2 times negative 2 plus 1. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. And then finally we input negative 3 for x. So 2 times negative 3 plus 1. That's going to be negative 6 plus 1, which is negative 5. So notice you have 3 ordered pairs that you can use to help you graph piece 1 of that function. Now, for the second part, we're going to input negative 1, 0, and 1 into that second rule. So you're going to do 3 times negative 1, which would be negative 3. There's an ordered pair. You're going to do 3 times 0, which is 0.
There's another ordered pair. And then you're going to do 3 times 1, which is 3. There's another ordered pair. All right, so we have created a function table for each of those rules. And now we are ready to graph this piecewise function. Now, your piecewise function is going to be in pieces. So there should be 2 different pieces, one for each rule. So there's my x-axis. And here is my y-axis. Now, to kind of emphasize what we're doing here, I am going to choose to graph these in 2 different colors. So I'm going to use red for piece number 1. So I'm going to graph the point -1, -1. So that's -1 on x, -1 on y, and I want you to notice that should be a filled-in circle because x was allowed to be equal to -1 for that function. For -2, -3, go to -2 on x, -1, -2, -3 on y. And by the way, all of the functions you're going to be graphing today should be linear. So you should get straight lines. If you're not, something is wrong. -3, -5, -1, 2, 3 on x, -1, 2, 3, 4, 5 on y. See how my 3 points are making this nice, pretty straight line? Now remember, this point is where it should all begin. Because when x is less than or equal to -1, right there is -1 on the x-axis, all the numbers less than are over this way. And keep in mind that this table that I've made is only a partial function table. I could have plugged in many, many more x values, but I want you to start at that first dot right there. And what I want you to do is I want you to draw a straight line through all 3 of those points, and I want you to extend it on and put an arrow on it. Because what I want you to do is show that that would continue. If I were to keep plugging in x values, this piece of this line would continue to fill up and would continue on. So that red is the graph for piece 1 of this function, for this rule when x is less than or equal to a -1. All right, now I'm going to switch to a blue marker for piece number 2. And the first point I'm going to graph is -1, -3. So that would be -1 on x and then 1, 2, 3 on y. Now when you get there, I need you to draw an open circle. Not closed. Open because x could only be greater than -1. He couldn't be equal. All right? Then you've got then you've got 0, 0. And then you've got 1, 3. Hang on just a minute. Oh, I know, hang on, I know what's wrong. I graphed that point wrong, didn't I? I had a moment, and you're not here where you can tell me, hey, what are you doing there? All right, -1, -3, let me try this again. That would be -1 on x, and then -1, -2, -3 on y. So right there is where your open circle should be. And the other 2 points were correct then. There's 0, 0, and there's 1, 3. So notice again how those are making a nice, pretty straight line. I'm going to start at this point because that's the beginning of the domain. And what you're going to do is draw your line through all 3 of those points and put an arrow to show that that would continue on to the right. So there is the graph for that piecewise function. Now I want you to remember here that if a function
that if a graph is a function, that it will pass the vertical line test. That if we draw a vertical line through the graph, it will only intersect the graph at one point. So you can see over here for this red part, that if I were drawing vertical lines, each one would only intersect at one point. So that would pass the vertical line test. And I want you to notice over here for the blue, the same would happen. That each part of that blue line would pass the vertical line test. So this is indeed a function. So I apologize for that little mistake there. So let me make sure I didn't confuse anybody. -1, -3, that first point I graphed, I did -1, +3. Threw me off there for a second. So -1, -3 should have been down here. So there's the graph for your piecewise function. Again, we make a function table for each part of the rule. Whatever numbers are specifically mentioned in the domains have to be in your table, which means some of them will repeat themselves. You've got to take the time to decide whether the circle for each one for that number, though, should be an open or a closed. All right, so let's try another one. All right, here's another two-parter. F of x is going to be x minus 3 if the domain is the x values that are less than 0. And f of x is going to be x squared plus 1 if the domain is the x's that are greater than or equal to 0. So I'm going to need to make two function tables. One for f of x equals x minus 3. And then one for f of x is equal to x squared plus 1. Now, you'll notice the specific number that is mentioned up here in both domains is 0. So I'm going to want 0 in both of these tables. One of those zeros will get an open circle and one will get a closed. This one will get an open circle because it's just x is less than 0. And this will get a closed because it's greater than or equal to 0. So I'm going to mark that just so I don't forget that little detail because that's pretty important. Now, I told you I want at least 3 numbers for inputs, so we only have 1 in each table. So for the first one, you're allowed to choose x's that are less than 0. So I would go with -1 and with -2, just to keep life nice and easy. And then in the second one, I can pick x's that are greater than 0. So I would go with 1 and 2 if I were you. So notice how I'm setting up my function tables. Whatever numbers are specifically mentioned up here go into the tables. And I need to think about whether that would be an open circle or a closed circle for that graph. And then I get to choose the other numbers myself based on what the domain says x is allowed to be. All right, so now let's input-output here. Input is 0 for this x. 0 minus 3 would produce an output of -3. Input -1. So -1 minus 3 would produce an output of -4. And then finally, -2 in for x. -2 minus 3 would output a -5 for the y. Keep in mind what you have just done is you have produced ordered pairs, x's and y's that are related. All right, same thing over here. Input 0 for x. 0 to the second power is 0 plus 1 makes an output of 1. Input 1. 1 to the second power is 1, plus 1 makes 2. Input a 2 for the x. 2 to the second power is 4. 4 plus 1 is 5. So again, I have produced ordered pairs that I can use to graph that piece of the function. Each piece gets its own table. Some of the numbers will be predetermined for you by the domains that are listed. The others you get to choose, but they have to fit the domain. the graphs you will be doing will all be linear. This x squared plus 1 part that I gave you to graph will actually not be linear. I'll show you that as we go along here. All right, so we're going to graph f of x equals x minus 3 first. My first point is 0, negative 3. That's going to be my start point. So 0 on x, negative 1, 2, 3 for y. I've got marked over there that needs to be an open circle, so I'll show that on my graph. For negative 1, negative 4, that's negative 1 on x, negative 1, 2, 3, 4 on y. And then negative 2, negative 5, 1, 2, 1, 2, 3, 4, 5. Nice pretty straight line by those 3 points starting here and going to the left forever. So make sure you draw a straight line through those points, make sure you extend it, and that you put an arrow. All right, now for f of x equals x squared plus 1, my first point is 0, 1. So that's 0 on x, 1 on y. You can see that that needs to be a filled in dot. 1, 2. And then 2, 1, 2, 3, 4, 5. So you can see that's not a straight line. Instead, what I'm getting is more of a curve. So I'm going to start at that beginning point and draw my curve and put an arrow up there on the end. So this would be a graph for that piecewise function. And I want you to notice again how this would pass the vertical line test. The only place where you have a vertical line that touches 2 of the points that we graphed is right here. Your y-axis touches that point and that point, but that one's open. That one's open. So that doesn't count as 2 actual points because that other one is open. So this graph would pass that vertical line test. All right, I want to do one last one with you before I leave you on your own. And I kind of thought for the grand finale we would do one that had more stuff. So f of x equals negative 2x minus 1 if your x value is less than negative 2. It's going to equal x plus 3 if negative 2 is less than or equal to x and x is less than 1. And it's going to equal negative 1 if x is greater than or equal to 1. So this time around we're going to try a piecewise function that has 3 pieces. So that means we will need 3 tables. So first, negative 2x minus 1. What number do I absolutely have to put in this table? Hopefully at home you're answering negative 2 because that's the only number that is specifically mentioned in the domain. Will that negative 2 on this graph get an open or a closed circle? Hopefully you're answering open. So I'm going to make a note of that right there. So I'll have it. And it gets an open why? Hopefully you're answering because it doesn't have the equal to part. Now I need to pick 2 more numbers. And they need to be numbers that are less than negative 2. So negative 3, negative 4 would be perfect for this job. All right, second table. F of x is equal to x plus 3. Make your function table. What numbers absolutely have to be in that function table? Notice this time 2 are mentioned. You got to have negative 2 and you got to have 1. And I want you to notice I left space, and I think you know why. Because notice where x is. X has to be between negative 2 and 1. Negative 2 has to be smaller than x, which means x has to be bigger than he is. X also has to be smaller than what 1 is. So I've left us a space there in the middle. That domain provides 2 of our numbers. Now I want you to notice negative 2 is a repeater. So I need to think about whether he would be an open or a closed circle. Negative 2 would be closed because we got the equal to bar with him. The 1 would be open because he does not have the equal to bar. Now, for my third number, I need to pick a number that's between -2 and 1. 0 would be a nice, easy number to use for that, so I think that's what I'll do. So notice, for these specific numbers up here that are mentioned, all of these specific numbers up here that are mentioned have to be members of my table for that function. And notice that for each one, I have to think about whether it's an open or a closed circle. For each of those specific numbers, open or closed. Everything else is going to be automatically closed. All right, and then for this last one, we have f of x is equal to a -1. We're going to make our table. The only number mentioned is 1. So I will get to choose the two others. 1 has an equal to bar with it, so that's going to be a filled-in circle. And the x's I choose have to be greater than 1, so 2 and 3, why not? Make life easy. So here would be the setup for this. So notice, when I made each of my 3 tables, I took these specific numbers from the domains and made sure they were in that particular table. I have to decide if they're open or closed circles, and then I pick my other x's based on what these things say about x. Hopefully that's all making sense. If not, you're going to let me know. All right, so here we go. Let's input, output. So we're going to input -2 for this x. So -2 times -2 would be +4, and +4 minus 1 is 3. Input -3. -2 times -3 is +6, minus 1 is 5. Input -4. -2 times -4 is 8. 8 minus 1 is 7. So I have now 3 ordered pairs that will help me graph that function rule. All right, input, output over here. -2 in for x. -2 plus 3 is 1. Input 0. 0 plus 3 is 3. Input 1. 1 plus 3 is 4. So for this part of the rule, those are my ordered pairs that I'm going to use to help me graph it. Now this last one is kind of interesting because I want you to notice there is no x in this function rule. So what this says is f of x is equal to a -1, and you know f of x is another name for what? F of x is the same thing as y, so this says that y is equal to a -1. So if I input 1 for x, this is going to give me an output of -1 for y. If I input 2 for x, it's going to give me -1 for y. If I input 3 for x, it's going to give me -1 for y. So no matter what the input is, the output is always -1. Now I want to make sure I say something here. This is a function. I don't want you to think because all those answers were -1 that it's not a function. It is. It is a function because for each specific input, I only got one output. So when I specifically put in 1, I got one answer, and that was -1. When I specifically put in 2, I got back one answer. When I specifically put in 3, I got back one answer. Doesn't matter that they're all the same answer. For each specific number that I input for x, it only gave me one output for y. Doesn't matter that they're all the same. All right, so now we're ready to graph. So this piecewise function had 3 different rules. So we should expect to see his graph in 3 different pieces. All right, I'm going to start with red for piece 1. -2, 3 is going to be an open circle. -3, 5. And then -1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So starting from that open circle, we go up and to the left forever. There's the first rule. All right, rule number 2. -2, 1.
0, 3, 1, 4. Pay attention to open or close. Now this one does not go on forever, because notice you had two definite endpoints. This is the start point, this is the stop point. Notice in these other two tables you only had one open or closed circle. So those go on forever. When your table has two of those in any combination, so two closed, two open, one of each, when it has two of the dots, that means that it does not go on forever. That is all for that function. Because think about it. It said the domain for that was -2 is less than or equal to x is less than 1. So the x's can only go from -2 to 1. So notice, -2 to 1, that entire graph has got to be complete. For this guy, it said x is less than -2. So from -2 on that way forever. So that's why that has that arrow on it. Hope that makes sense. If not, again, you'll let me know. All right, so let's get this last one. 1, -1. 2, -1. 3, -1. And again here, notice this says that this is for x is greater than 1, so starting at 1 and then going this way forever. So this will have an arrow. So there's your piecewise function. And notice this graph would pass the vertical line test. I want to make sure that you see something here. Even though right here you have a vertical line that has two of the dots on it, one of them's open, so that doesn't count. And again here, there's a vertical line that would have two of the dots you made on it, but one of them's open, so that doesn't count. There's not really a point there, it's open. So this would pass the vertical line test. It is a function. So let me, for this last one, kind of recap a couple of things before I leave you. I want you to notice that we had to make 3 function tables. These numbers are the numbers that have to appear in my table. So the first one had to have a -2, and he's open because there's no equal to. This table had to have -2 and 1. -2 would be closed because there's an equal, and 1 would be open because there is no equal. And then this last table had to have 1, which would be closed because there's an equal. And then you have to fill in as many numbers as it takes for you to get to 3 points. I want 3 points on each section. How do you know when it goes on forever versus when it doesn't? Well, for this one, x is allowed to be anything less than -2. So think of starting here at -2 and then going forever that way. Because that's what that's saying, that x starts out at -2 and then goes forever that way. So this gets an arrow because x is less than -2 doesn't stop. But that next section says that -2 has to be less than or equal to x, and x has to be less than 1. So notice there are 2 numbers there. So the graph starts when x is -2 and stops when x is equal to +1. It's as far as it goes. It does not go on forever. And then for that last one, x is greater than or equal to 1, so it starts off at x equals 1, and then it goes forever that way. X greater than 1 doesn't stop. So that's how you'll know whether you need arrows or whether that graph stops. Now, that's a rundown on how you graph these piecewise functions. Tomorrow, you will be taking a quiz on everything that we have done so far with functions. So you will need to be able to look at something and say, yes, it is a function, or no, it's not, which is what we started this unit with. You will need to be able to graph a function by making a function table, which we have practiced, again, for the last couple of days. You will need to know about function notation, f of x, and how to evaluate that. You will need to be able to work with composite functions and with piecewise functions. So look over all of the things that you have done so far today with functions, and if there are any questions before we take this quiz tomorrow, be sure and let me know.